Hello and welcome to my YouTube channel FPJ Made Easy. On this channel you will learn about the FPJ technology and programming from basic to advanced level. In this series of videos we started to learn about Verilog HDL from basic to advanced. For more videos subscribe to this channel and follow us on our Facebook page for the notification. In this video our learning objective is to discuss few more data types. In previous video, whose link is given in the description, we discuss few Verilog data types. Whereas we will discuss the following data types such as integer, reals, times and real times, arrays and parameters in this video. So let's start. Verilog HDL supports integer, real and time register data types. Let's start with integer data type. Integer data type is a general purpose data type which are used to manipulate quantities that are not regarded as hardware register. The keyword to declare this data type is integer. The width of integer is dependent on host machine word size, or we can say it is an implementation specific, but normally it is considered as 32-bit wide. The integer data type stores values as signed quantities. For example, we have shown here some integer declaration. In first statement, A, B and C, three identifiers or variables are declared as integer data types. Now the width of these three variables are 32-bit each. In other statement, variable counter is declared as an integer data type. In this example, a -1 is assigned to this variable. It stores it as signed value. Now another data type is real. Real number constant and real data register types are declared with the keyword real. Real numbers are already discussed in the topic real numbers in lexical tokens. The link for that video is given in the description. In that video, we have explained it that real numbers cannot have a range declaration and their default value is 0. If someone assigned a real value to an integer variable, then the real number is rounded off to nearest integer as shown in the example. Also, real numbers are specified in two ways. The decimal notation such as 3.14 or the scientific notation using exponential notation. Example shows the declaration of real data types variable and how we can assign real numbers to the real data types variable. Another data type is time data type. Verilog simulation is done with respect to simulation time. In order to store simulation time, Verilog HDL provides a special time data type and it is declared with the keyword time, like integer. The width of time data type is implementation specific, but it should be at least 64-bit wide. The system function $time is invoked to get the current simulation time during the simulation of the design, as described in the example. It is measured in terms of simulation second. Now the fourth data type is real time. The real time declaration is treated same as real declarations and can be used interchangeably. It can be defined by the keyword real time. Here are few examples which shows the declaration of integer, real times and real times. Arrays are collection of elements which can be scalar or vector. Arrays are allowed for every data type such as reg, integer, time, vector and except the real variables. It should be noted that multi-dimensional arrays are not allowed in Verilog HDL. Some examples shows the various array declaration for different data types. In the first example, we can see that integer count 0 to 7 is an array of 8 count variables where each variable, each element of that array is 1 bit. Similarly, rect bool is a 32-bit 1-bit boolean variable. Similarly, time, reg and integer. Here a matrix, if we want to describe the multidimensional array, it is illegal and not allowed in Verilog HDL. We can also access the elements from the array as count of 5, then the fifth element of an array of count variable. Similarly, check underscore point of 100 means 100th time checkpoint value. Similarly, we can access like a C language. It is important to note that you must not confuse between arrays and vectors. A vector is a single element that is n bit wide. Arrays are multiple elements and each element can be of single bit or a n bit wide. So the easiest way to remember the difference between array and vector declaration is the range of vector is given in between data type and an identifier. Whereas in an array, the range is specified in the end of after the identifier. So here we can see the example reg 0 to 3 count. Count is a vector of reg data type and it of 1 bit in width. So if we move horizontally, then we are moving on the size of a variable and it is called vector. Similarly, when we move vertically, then we are considering the array. This count variable is an array of reg data type and consists of 4 elements of 1 bit in width. So here are some exercise examples where you have to tell me in comment section that how many rows and columns of this count 1 and count 2 variables will be. So I will wait for your answer in the comment section. In digital simulation, one often needs to model register files, RAMs and ROMs because in many designs we need to store some data, so we need memories. So memories are modeled in Verilog simply as an array of registers. Each element of array is known as a word. Each word can be 1 or more bit wide. It is important to differentiate between n 1-bit registers and one n-bit register. A particular word in memory is obtained by using the address of the memory array subscript. For example, mem 1 bit and in the range is a memory with 1 kilo 1 bit word. Reg 7 to 0 mem byte and memory byte with 1k 8-bit word. Similarly, if we want to access or fetch some word, then we will write mem byte 511, then 511, the data at the 511 location will be fetch. That byte will be fetch. Verilog allows constant to be defined in a module by the keyword parameters. Parameters cannot be used as variable reg or a net because they are constants. Parameter values for each module instance can be overwritten individually at compile time. Parameters can be changed at module instantiation or by using the statement define param, which is define parameter. It is illegal to redeclare a name already declared by a net parameter or a variable declaration. For example, port ID is declared as a parameter and assigned a constant value of 5. Now this port ID variable cannot be redeclared as a reg variable data type or a net data type etc. Thank you for watching this video. For more videos, subscribe to this channel and follow us on our Facebook page for the notification. Thank you.